recording, it'll go to cloud.
Okay, yeah, someone's doing it. Okay, let me screen share first. Share screen. Okay. So this is the PDF of exam 2 practice problems we're gonna go over. Give me 1 second. Let me do this. Copy, paste, and copy. Okay. Okay. So this is our first question. By the way, I'm not looking at the chat. So if you guys have any questions, there is Solomon there. We'll be answering the chat questions. Okay. So this is our first question. There are 4 parts, basically outputs. So you will look at the main function, which is part of this one, and you will see the line A, line B, line C, and line D. So this is part of the object-oriented, or I would say inheritance portion of the course. If you guys don't know what inheritance is basically when one class is a child of another class. So for example, I'll just go over this one and then I'll just explain what inheritance is along the way. So in the main function, the first line we do is we create a new instance of a type B class and we name that as small b. So basically B is a type capital B class. And then the next line, we make a small, we put the small a variable and that refers to that small b. And what is our small b? The small b is also capital B. So you can like kind of think of like the small a points to a small b and the small b is basically type capital B. And why did she use a capital A? That's because of the inheritance. So if you look at the this portion, you can see this line says class B extends A. And what that basically means is A is our parent class and B is our child class. So that means in class B, like in this class, everything from class A is inherited. So if class A has a method called method 1, you don't need method 1 to be declared in B. You can use that method 1 from class A when you are in class B because class B is inheriting everything from class A. So this is our current structure and we'll see what the question asks. Okay, so the first line is this one, which asks what does system.out.println small a does. So then again, where's small a? Small a points to small b and small b is a type class B. So now I'll go to class B because that's our type right now. And class B is this portion. And when you call system.out.println and you pass in a class, it basically calls the toString method. So I'll go to class B's toString method, which is this one. And what does it say? It returns this line. So it returns class B colon space and then this variable x. So now what is variable x? There is no variable x in class B, right? But there is a variable x in class A. Remember when I said class B is inheriting everything from class A? So if class A has a variable x, you can use that x from class A in class B. And since we did not change anything yet, so my current value of variable x is 0. So here class B colon is 0. Any questions so far? Okay. So the next line goes to part B, which is what does line B generates. So now we are done with this one. And then we go to this line. This line says B dot increment. So the first thing I do is I go to class B and I try to find this dot increment method. But then again, in class B, there is no dot increment method, right? So what do I do next? I go to its parent class. So now I look for dot increment method in class A, and I can see that class A has this method, increment. And what does increment does? Increment basically updates the current value of x and add 1 to it. So when it was x equal to 0, now is x equal to 1. And since we are using the same variable in class B as well, because class B doesn't have any x. So for example, if I try to print x from class B, it should print 1 because the x was changed in class A. So now when we call this one system.out.println line A, it's gonna try to check what is A. A is a type B, right? So it will try to see the toString method in class B, because when you print a class, it basically checks the toString method. So it will go to the toString method and it will print class B colon space and the value of x. And the current value of x is 1, so we print 1 here. Cool. So the next line is this one. What does line C prints? So after we're done with line B, now we go to this one. And what this line does, remember when we did A is pointing to B and B is a type capital B? Now A is a new instance of type A. So now this one doesn't exist. So now A is basically a new class of type A. A doesn't refer to B and B doesn't refer to capital B. Like that doesn't exist anymore because we just changed the small a to capital A. So now we go to the next line, which calls small a dot get B. So I'll go to that small a. Small a is a type capital A, and I'll go to capital A's class and I try to find the get B method. And I can see that in the capital A, we have this get B method. And what does get B do? Get B returns a new object of type B. Okay. So then when you call this thing, like when you make this stuff new instance of type B, this basically makes a new instance of this class, and then that calls the toString method of that class. Even though small a is a type capital A right now, we don't do this one because we call the get B method, and this get B method basically returns a new object of type B. So it's kind of like the same thing we did on line A, right? Because we are going to B class, and then we're invoking the toString method of B class, which says class B colon X. So I'll go here, and from here, I'll just do the same thing, class B colon. And now what's the value of X, right? Remember, when we crossed out this pointer and we made a new instance, every time you make a new instance, everything happens like over and over again. So for example, when we made a new instance of class A, I just changed my current value of X to 0. So this X equal to 1 was when I had this connection. But now this connection is broken, so this one doesn't exist. So now when I made this new instance of A, I just made a fresh new variable x equal to 0. So now when I try to print this line, my x value is 0. So that's why I print 0 here. Any questions so far? Cool. So now I go to the next line, which is this one. So now I I go to B. Remember, I only broke this connection. I never broke this one, right? This one still exists. Like the small b is a type capital B, this one still exists. So I'll go to small b, which is a type B, and I'll try to find this method, which is get A. So I'll go to the class B, and I'll try to find the get A method. And I can already see that in the class B, I already have a get A method. And what does get A method does? It calls get B. And you can already think that this is the same thing is going to happen because get B is basically what we did on the last part, right? It's going to call get B on the parent class because B is inheriting everything from A, right? And then you'll go to get B method. And what does get B does? It makes a new instance of type B. And obviously it's gonna invoke the toString method again, and it's gonna return the value of X because we never changed X. Or even if we changed X, just because we made a new instance, it's gonna, whatever I changed before, it's gonna be overwritten with a new, fresh new value of 0. So when I go to the line D, it basically does the same thing we did on part C, which is class B is equal to 0, and the value of X equal to 0 because we made a new instance of B. Any questions so far? It's just you follow the lines. Basically, you know what B is. B is inheriting everything from A. And then you just, write like what's pointing to what. Like I only made this connection. A goes to B and B is a type capital B because of this line, right? Because A is now a pointing to a reference of small b. And what is small b? Small b is a type capital B. Okay, so I'll go to the next question, which is, okay. This question 2, and the questions are 3 parts. Okay. Okay, cool. So question B. So the first part says, create a class. By the way, is it too small to see? I gotta see the whole thing in order to answer, so I can't even zoom in. Okay. So it says create a class called square, and that is a subclass of rectangle. So then again, it's the same thing as we did the last time, which is inheritance. Square is gonna come from rectangle because square is a subclass of rectangle. And it implements the interface shape. So interface is basically it's like this thing where you only write the title lines, or you only call the functions, not calling the function, but you only write the title lines, but you don't implement them. You implement them in a different class, which is this portion where it says we're implementing this interface shape. So this area method is being implemented in this rectangle class, but the shape just have this thing. And the rule of interface is basically whichever method you say is gonna be in here, you have to implement them. Like when you call implement shape here, you have to implement all these methods. So there's only 2 methods, so you have to implement 2 of them. So the part is implements interface shape in the package squares. Add a field called count to this class to count the number of squares created by the program. Okay. So since they did not say whether it should be public or private, you can always assume it's public. Because I'm not gonna how should I do it? Can I put a text box? 1 second. Um, insert. Whatever. I'll just do it and I'll drag it in the inside the box. So there we go. Oh, okay. So since they did not say whether it should be public or private, I'm gonna assume it's public. And I'm pretty sure Professor Chin would not care about the small stuffs. And that she didn't even mention whether it should be public or private. So first things first, you go line by line. So it said it should be a class called square. So I'll go to public class. It should be small p, not capital P. Okay, it's bothering me to be honest. How should I ignore this one? Actually, you know what? I know how to do. There you go. Okay. So it should be public class and the name is square because it's written in the question. And it's a subclass of rectangle. That means if you go back to the question one, how do you know which is subclass of what? Is like this. It extends this A and A is our parent class. So our square should extend from rectangle. Extends rectangle. And then it said we should also implement the interface shape. So I'll also do implements shape, and that is my title, or basically the class name. And inside we want to do what? We want to add a field called count to this class to count the number of squares. So basically like it's a variable, that's it. So I'll go inside. I'll go inside and I'll make a new variable called int count equal to 0. Because it always start from 0, right? And then again, you need like the type. I'm gonna put public. And since I'm not so sure whether it matters if you put static or not, because static basically means it's the static variable, like a global variable, but there is nothing else going on before this. But I'm gonna assume it's gonna be static. So I'll just put it in. So there's nothing else to do on part A because she only asked to add a field that counts that has the number of counts, how many times you call the square. So that's it. So now go to part B. Part B says implement a constructor of this square class I just made. And we also need to update the variable we just declared or we just initialized. So it's gonna be the same title line as the part A, which is public plus square extends rectangle implements shape. And we also have this variable public static int count equal to 0. And then we need to do the constructor. So constructor is when you basically when you make a new instance of a class, you call the constructor and you pass in some values. So the constructor always has the same name as the class name. So if your class name is square, the constructor should also be square. So I'll do square. And I'm also assuming everything is public for now. And then let's see. Okay, cool. Okay, so square, if you look at the question, square is being called like this with only one parameter, right? Like here as well. So when you make the constructor should only have one parameter, and which I'm gonna call I don't know, length. And inside, since square is coming from rectangle, so I'm gonna go to the rectangles constructor, which is this portion. And I see that rectangle gets two parameters because obviously rectangle doesn't have to be same sides everywhere. And these two parameters are basically the set to the attributes of that class. So the way I'm gonna do it by calling the rectangles constructor is with the keyword called super. The super basically goes to the parent class. Our parent class is rectangle and calls his constructor. The superclass should take two parameters because rectangle's constructor has two parameters. And so I'm going to pass in the same value twice because in the square, the height and the width are the same thing, so it doesn't really matter. And that should be it. Oh, by the way, I missed something. So it also said, remember to update the variable count. So after we call it, I should also update this count variable. So I'm going to do count plus equals 1. Or you can just do count plus plus. Doesn't really, it's the same thing. Okay, so that concludes this portion. And then I also have write only one method called toString that returns the string square. So I should also write one more method after the constructor called toString, and it's also returning the string square. So the return type should also be string. And I'm gonna assume everything is public for now because she did not mention basically anything. And this should return the string square. So return square. By the way, in Java, this method is default. Like this toString method, when you when you make a class, Java automatically assigns this toString method. So when you try to change the toString method to something you want to do for this class, it's good to write this thing over the method called add override. It's just when you compile the code, it basically tells the compiler, oh, hey, the following method is going to be overwritten because the following method was a default. But we're changing the default to something else. So that's why I think it's optional. Even if you don't do it, Java will do it for you, but it's always good to write override if this method is a default by Java. So that should be it for our part B. And then I'll go to part C, by the way. Okay, so nothing else. Okay, so part C. Part C says write the output of each six parentheses in the main function. Okay, so it's this portion basically. A, B, C, D, E, F. Okay, so in the main function, I go line by line. The first line says S is a new square and we passed in 3. Okay, so basically S is a square, SQUARE, and the square's length is being passed as 3. So when you call the super in the rectangle, it's kind of messy. When you call super in the rectangle, this portion, length and width are both being passed as 3 because I basically called the same length twice. So then when I go to this line, system.out.println s.perimeter, I'll look at s, which is type square, and I'll try to find the dot perimeter method. If you look at my square, there is no perimeter method. So what's the next thing to do? Look at the parent class, which is the rectangle, and try to find the dot parameter method in that class. And if you look carefully, there is this parameter inside the rectangle class. And what does parameter does? Parameter basically adds the length and the width and times it by 2. And remember, our length was 3 and our width was 3 because I called 3 in here, and that 3 was passed twice in the super. So this thing is gonna do 3 plus 3, which is 6, and 2 times 6 is 12. So when you go to this one, this portion, I'm gonna do, let's do green. Oh, whoa, why is it highlights? This portion, this green portion is gonna return 12, and that's what's gonna be outputted um in my line A. Okay. So now we're done with line A. Let's go to next line. Next line says this one, which is P is also a new square, and now we pass in 5. So what does it do? It goes to squares constructor, pass in 5 here, and it calls length in the super 5 and 5 because both are the same thing. And in the super, we go to the rectangle class, and now both of them are 5. So now when I called this method, p.toString, p right now is square. So I'll go to square method and I'll try to find, is there a toString method? If I look in this class, there is a toString method, which is this portion, and it basically returns this square with a small s. And since we're not going anything else, and that should be my output, so part B, line B should print just square. Square. This square basically came from this square. Cool. So next line is this one, which is rectangle R. R is also a new square, and we pass in 6. It's gonna do the same thing. I'm not gonna go over again. It's basically length is 6 and width is 6. And then when I go to system, there's a typo. Is system.out.println R. Remember when I said when we print a object, it always invokes the toString method. So I'll try to find the toString method inside this rectangle class. And if you look carefully in the rectangle class, there is a toString method called this one. Oh, no, 1 second. Actually, no, because this is a type. Okay, it's the same thing we did on part A. It's kind of like this. R is a new instance of square. So when I do system.out.println R, it basically goes through square and tries to find the toString method in this class. If this class doesn't have the toString method, then it goes to the parent class, which is rectangle, which I was telling you earlier. So basically, since we made a new instance of a square, so I'll go to the square class, which is this one, and I'll try to find the toString method, which is this portion, and this portion returns square, like similarly as as question 2. So this should also print out square. Only way it would print rectangle if this one was new rectangle instead of new square, right? Okay, so this one is done. A, B, C is done. So now go here. Now it's the same thing we did earlier, which is the square was passed in every time. Remember, every time we make a new instance. So whatever we did the last time is being gone away because it's a new version of this class. It's a new instance of this class, and every time we're passing in different values, so it doesn't really matter to us. So now our value is 3. So our length and width are both 3 on the rectangle as well. So when I call this line, which is s.area, s is a square. So I'll go to the square class and try to find, is there a dot area method? Is there a dot area method in this portion? There is not. What's the next thing to do? Go to the parent class, which is rectangle, and try to find the dot area in that portion, which is basically this line. And since my length and width are both 3, we just multiply them, which is 9, and that should be returned from this green box. So when I call system.out.print line s.area, this should just print out 9. 9. Any questions? Oh, so now we're done with this, and we go to the next line, which is now we're calling P, and P is also a new square, and we passed in 5 as the constructor, so our length is 5 here. And then the next line says P dot perimeter. It's going to do the same thing. It will try to find the perimeter method in the square class because P is a square. There is no perimeter method. What does it do? Go to the parent class, which is rectangle, and find the perimeter method, which is this one. And since super passed in the same value twice, 5 and 5, so right now my length and width are both 5s. And this method, when I call perimeter, it should do 2 times 5 plus 5, which is 20. So this line should print 20. So then we go to the next line, which is rectangle R. Then again, it's also a new square. And when I call the R dot area, it basically checks the dot area method in the square. And since there is no dot area method, we go to the parent class, which is rectangle, and I call the dot area method, which is this one from here. And this one basically, since we passed in 6 here, this length and width both are going to be 6. This is a 6, this is a 6. So the dot area basically multiplies 6 times 6, which is 36. So this should be 36, and output of line F should be 36. Okay, so that concludes our question 2. If there's no more question, I'll go to question 3, which seems like another output question. So I'll just do this. Okay. And we have some, some printing. Okay, so when they say what is printed on line A, so line A is inside the main method. So we'll go line by line. The first line says A is a new instance of C. For this question, since there's so many inheritance, I'll just draw the structure first, then I'll cover the questions because it's going to be easier for us to visualize. So class B extends class A. So basically A is a child of B. Class C also extends class A. So C is also a child of A. Now D also extends A, so D should also be another child of A. Then E extends B, so E is from here. And then F also extends B, so F is right there. So what this means is basically if you look at E, you can access everything from B and everything from A because they're their parents and grandparents basically. This is my current structure. And when I go to this line, A is a new instance of type capital C, which is basically this portion. So we have an instance of A, which is a type capital C. So when I go to system.out.println a.what, I'll try to find, is there a .what function in class C? If you look at class C, there is a .what function, and that basically returns the word returning space capital C. That's why it's returning space capital C. Actually, I'll just do it with you so you can see. This one, returning C. This is my basically this is my line A actually. Okay. So now we go to the next line, which is this one. This one says A1 is a new instance of type E. So A1 is a new instance of type E, which is kind of like this one. So when I call A1 dot method, we'll try to find is there dot method in class E. And if we look at here, we do have the method function, and that basically prints out E dot. This is not like we are not calling it because there's a string, like there's this quotation marks. So basically like literally E dot method and then parenthesis open parenthesis close followed by a space. And then we'll print out ch is being passed in. So if we look at here, the ch is our capital X. So that means when I print it out, it should do something like E dot method parenthesis space X, because X was passed in here. So my ch is X. So this one prints X. So then we go to the next line, which is this thing. This thing says B is a new instance of capital B. So like this one. So B is like this thing. So then when I call b.adjust, I'll try to see is there an adjust function in class B. If you look at this one, there is an adjust function, and that basically prints out adjusting B. So when I call this b.adjust, since this is printing, it will just print out right away. That's why we did not need system.out.println at this part, because it's just printing inside the function, right? So this portion, line C, should do adjusting B, adjusting B, because we have an adjust function in class B, and that basically prints out this string adjusting B. So then I go to the next line, which is this one, B1. Now B1 is a type capital F. So basically B1 is this thing. So when I call B1 dot what, all I'm trying to find is there a what function in type F, I mean in class F. If you look at here, there is no what function. So what's the logical thing to do? Go to its parent class, which is this one, and see is there a what function in class B. If you look at class B, there is a what function. And what does it do? It returning a capital B. So when I print it out, this part basically returns the string returning capital B, and we just print it out. So go here, returning capital B, right? Uh, yeah, this thing, returning capital B. So now this one is done as well. Go to the next line, which is A2, and A2 is a type D, basically this thing. So then when I'm not so sure what this typecasting is doing because A2 is already type D. This thing is basically casting it. I'm sure you guys learned about this thing in 111 where if you have a character 1, you can cast it with an integer um, integer C int x equal to. So you can do this because C is like a valid kind of like an integer. So when you do typecasting, this x is basically storing the value 1, not the character 1, because x is a type int. So this is what this casting is doing, but I'm not so sure why she did that because A2 is already a type D. So when I call A2.change, all I'm trying to find is there a dot change method in class D. And if you look here, there is a change method. And what does it do? It prints changing string. So when we call this line, it should just print out this string called changed string. So my part E should be CHANGD space STRING. And that's about it. Any questions so far? If not, I will move to question 4. Okay. So question 4 is 3 parts, and we have some interface stuff and we have some output stuff. Okay. So this is my question 4. So part A asks for something, part B asks for something else, and part C asking for outputs. Okay. Okay, so part A says write an interface A that requires the two print message methods. So if you look at the thing in the question, so there is this main method and there's this class called class B, and class B is implementing the interface A. And so basically what she wants us to do is type out the interface just like we did last time, which is gonna be, I mean, the last time she gave out the interface, if I'm not mistaken, right? Like here. she gave the interface, but she wanted us to implementing the methods. But this time, she gave the methods and she wanting us to implement the interface. So it's gonna be like this. Then again, I'm gonna put public because when she doesn't mention what should be public or private, just assume everything is public. A public interface and the name is A, and we want to require the two print message methods. So if you look at this one, there is this method, there is this method, there is this method. Even though there is three methods, she only wants you to require the two print message methods. So you can kind of like skip or ignore this print answer one. You just want to do the print message with 0 parameter and print message with 1 parameter. So I'll go here and I will type in print, is it a small m or capital M? Capital M. MESGE with 0 parameter and print message with 1 parameter. And obviously these methods need to have return type. So if you look at there, both of them is returning type void. So in here, you come to you just write void in front of it because they're the return type when they were implemented. So that's my part A. I'll just do it small. Okay. So then part B says write a subclass. So every time you see the word subclass, that basically means the inheritance we were talking about all this time. So C is going to be a subclass of B. So kind of like this. And that has only one method. And the method should override the method, this one, print message, and make the overridden method print out this thing. Okay. So I will write class C, and that is extending B because it always says C is going to be subclass of B, and I'm going to put public again. Okay, and she only wants you to write one method, which is this one, public void print message with 0 parameter, and that method should be overwritten, and that should print out this thing. So if I put that all together, it's gonna be public void print message, and that should just print out system dot out dot print. The answer is 42. Okay, and since she also wants you to override it, you should also write down this thing, override. Then again, this is also optional. Java automatically assumes if there is a print message in the parent class, which is class B, and I can already see there is a print message method with 0 parameter in the parent class, it will automatically override it. But it's always good to write it like that. Okay, so I'm pretty sure that should be it for part B. ignore the red line because it's, oh, whoops, whatever. So that should be it. I made one method, I override it, and this is my method. This is my method, and that is printing this answer. So then I go to part C. Part C is basically outputs of the main method. So, and then we have a couple of things. We have here, here, and here. Okay, so first things first, we do A. A is a type C. So A, whoops, A is a type C. So A is kind of like a new instance of this class. And B is a type B. So B, small b is a type of capital B. So then I call A dot print message. So when I call A dot print message, what it should do is it should go to class C, and is there a dot print message? So if you look here, there is a print message, which is this one. Okay, it's like kind of bothering me. Ignore. Okay. So then I'm gonna look at this method in the class B. I mean, sorry, class C, because our A is a class C. And then I'll go inside and I'll just print out the answer is 42. So here it should be, this is basically part C's answer. And that's it. We don't do anything else in the print message. So this should be good. Go to the next line. Next line does b dot print message. So I'll go to B, the small b is a type capital B, and I'll go to capital B class, which is this thing. And is there a dot print message with 0 parameter? And there is a dot print message, which is this thing that I'm erasing right now, this one with 0 parameter. And what it does, it first calls print answer, and then it prints out this thing. So I'll call the print answer first. Print answer is this thing. And that prints the answer is, that's it. Okay, I guess, yeah, that's it. So I don't know why she put the answer is, but yeah, it should print out the answer is. And then, oh, I see what's going on. So this one doesn't have a line. This is just printing, but this one has a print line. So when I'm done with this one, I'm not gonna come from here to here because we did not do print line. So my cursor will stay at this position, and at this position, I'm gonna print the next line, which is unknown. So it's gonna be like the answer is unknown. It's unknown came from this line, and the string, the answer is this came from this portion. And the reason we didn't go to the next line because this one was a print, not a print line. So that is my this line is done. So then I'll go to the next one, which is this thing. So here, what I'm doing is right now my A is a type C, and I'm typecasting it with a type B. So basically kind of like this. B is going to be a type B because it's being casted from a type C. Because A was a C, right? A was a C, and we cast it to a type B. So right now my B is kind of like actually type B, or actually C, but that's casted to type capital B. And when I go to the next line, which is B dot print message, I will first go to what it was before, which is type C, and then I'll try to find the print message method inside this class. And if I look at it, it just basically prints the same thing as this line, which is the answer is 42. And I will type it down. The answer is 42. And does it do anything else? No, because typecasting does. Okay, so I cannot guarantee if this typecasting also calls the print message on type B, but someone has to fact check me because I'm not sure. But in my opinion, this should be my answer. But either we call the print message on type on class B, which is this one, right? Oh, no, actually this one, my bad. This one, because we passed in we passed in a parameter. It wasn't like a no parameter one. So it would either be that or nothing. It would either be this one or where we call it or we don't call it, but I'm not so sure if we are gonna call it or not.
The last one, I think we call it, so it prints, the answer is 42 two times, the last one.
Oh, okay. So I guess we call it one more time because we cast it. And if we call this one, oh no, I see what's going on. Actually, yeah, my reasoning was wrong because X was 2 times. That's why. Okay, yeah, I see. Yeah, so ignore everything I said on the last 2 minutes. Um, okay, so when we do this thing, casting, it is not gonna look at C, but it's gonna look at B. Remember when we did this thing? Right now, my X is integer 1, not the character 1, right? Because the character 1 is being changed to integer 1. So when we cast the small a to capital B, right now my B is actually a type B because we casted the C to a B. So when we call print message, when we call this one, it's actually going to call this method from this class, not from this class. So if I call it from this class, print message with one parameter, which is this portion, and from here, I'm gonna call print message with so this one basically is a loop, and this loop runs however many this x many times, and x is basically our 2. So we're gonna call print message 2 times, right? And 1 second. So why does it print 42? Shouldn't print the answer is unknown 2 times? Okay, I guess, yeah, I'm not so sure, but if the answer is 42 2 times, I guess when I call print message from this portion, this actually does not invoke the print message on the current class, but it invokes the print message of whatever it was originally, which is this portion. And this portion basically prints out the answer 42 2 times. So I guess that's why it does it twice from that portion. Yeah, so I say if the answer is correct, then that's what it does. When I call print message here, it does not call print message from the current class, which is this one, the green box. We don't do that. We go to the original class. The original class was type C, and we call print message from this portion, which is the answer is 42 2 times, because x was 2. So that should be my output for question C. Any questions so far? If not, I'll go to the next question. The next one is a GUI stuff. Suleiman, can you take over this part?
Yep, I'll take over the next two GUI questions.
Okay, I'll
All
stop
right.
screen sharing.
Thank you, Zion. Share my screen. Okay, so here's the dealio. I'm not much of a GUI person. I think Lord goes really in depth on the GUI. I took it with Akinlar. He only did GUI on the last like day, wasn't even on the exam. So, and for this question, it's less reasoning. The GUI question, it's more about memorization. So what I'm gonna do, wait, actually let me share my entire screen. Share screen. Is it showing the entire screen? Entire screen. Okay, but never mind, we're good. All right, so we're good. Okay, so this is a question. Basically, we're asked, write a Java program that creates and displays the following GUI. In this problem, there's no need to program any listener option response to user actions. So it's just asking us to create this GUI. You don't need to like implement any interaction with the user. Whereas here, the only interaction we have is when the user clicks the exit button, it should, on the first time it clicks it, it should print, are you sure in red? Second time, are you really sure? And third time, it should exit. So, like I said, this question, whereas the last few questions that you could like reason it out and you use, these are more like not knowing about object-oriented programming. The GUI, you just gotta like memorize and like know how it is, right? So I'm just gonna, I think I went through this step by step on the exam 2 review, but I'll go again really briefly. So for the first part, whenever you use GUI, Java has libraries specifically for it. So we have to use swing. These two are for the action listeners. So in general, whenever you use anything GUI related, you have to always import Java X Swing. There are other libraries as well, but for this simple thing, you could just use Swing and AWT. This is for the to interact with the user, so with like button clicks and stuff. And yeah, so we extend JFrame. Once again, most of this you gotta memorize. If you want to add a label, display label right here. So we have this display label right here. Let me zoom in a bit more. I got this display label. We add a new display label. And close attempts, we're gonna use these close attempts. This is for the second part of the question, where we have to keep track of the number of times the user clicks the exit. So we're gonna use this for the close attempts. And these we just had to set the height and width of the thing, right? Width is 600, height is 400, set that, right? Public static, final means we don't change it. So yeah. All right, so language demo. This is like the constructor for it. So this is when we construct the actual GUI. See how it says super editor GUI, then we set size, height, and width. Like the super, this is because we extend JFrame. So a lot of this comes from JFrame. So we set the label for it as editor GUI. We set the size of it, height and width, as we already defined. And then we want to add a window listener. This is also for the second part, where we create a new window destroyer function that keeps track of the number of times the user clicks the exit button. Right here, right? So this portion right here is for the second question mostly. And initially we want to set a default close operation, JFrame do nothing on close. As I mentioned, I'll mention it again. These things you can't really reason out. You just gotta straight up memorize it. I doubt she's gonna give something too long, right? Like most of these, like if you see it, it's not too difficult to memorize. Like if you want a new menu bar, you have to include JMenu. You can name whatever you like. Equals new JMenu. Label it whatever you want. If you want to add new items, you have to create a new item. Like you see, as a JMenu item. Most of the names are self-explanatory. A new JMenu bar, new menu bar. You want to add the menu and you want to add an option, which means when you click this language, it should add an option, add the options, right? So our first option, our first item, English to Spanish, we add it. Second item is Spanish to English, we add it, right? So they're all added onto the bar, menu bar. So when you click it, as you see, English to Spanish, Spanish to English, pretty straightforward. And then, okay, so this is a container content pane. So this is everything below it. So this is this portion right here. Okay. And we want to set layout, new border layout. Ignore, you don't really need to know what this is. For now, just accept it as is. If you ever take CS355, this is just basically like CSS. I'm not sure if any of you have heard of that. It's like how you lay out the website, the styling of it. So for now, I just say accept it. Same thing here. J panel, editor panel, new J panel, grid layout 5:1. And so that's for this. 1, 2, 3. I think it's 1, 2, 3, 4, 5. And this is the footing. Yep. Border layout, grid layout. This is like 5 rows, 1 column, I believe. Okay. Please stop me if you guys have any questions. I'm just going through this because I feel like this isn't, you can't really like study for this. It's more like memorizing and knowing what each part does. And I'll show a quick demo of it because I have it loaded up and how each of them works. Until then, so that's why I'm like briefly going through. And also if you like want, I think I did also do a in-depth run through of it on the exam 2 review, which I will show you guys where that is later. Okay, so once again, we're adding a new label. We add it to the editor panel. We want to add another label, type your text here. We add it to the editor panel and we add it to the content pane. So that's right here. Type your text here. And we want to add a text input area. For that, we have to, what do you have to create? A text input field. So a text field, input field equals new J text field, and you add it to the editor pane. Like I see, like I hope you guys are trying to see a new pattern here, right? It's just, like I said, most of this is memorized. You want to add a new label, boom, J label, modified label, new J label, modified text. You add it to the editor panel. And then another text field, J text field, input field 2 equals new J text field 15. Add it to the editor panel. And now we want to add buttons, right? So we want J panel button pane 1 equals new J panel. So that's this little pane right here for the buttons. Right. This is flow layout. So grid layout is more like, so an actual grid. It's a very bad grid, but you guys see my point. Grid. Maybe sorry to see that. You can edit like the direction of it, but flow layout is more flexible. Once again, you'll learn this terminology and what these things are. If you ever do take CS255, for those who will, you learn a lot of you learn about HTML, CSS, how you could lay out various parts of the website. So we added to the content pane, border layout south. Basically means we're adding it to the bottom of the content pane. And then we're adding new buttons. So J button, check button equals new J button, whatever label you give it, you add it to the button panel. Another button, translate button equals new J button, translate, you add it to the button panel. Okay. And the main idea is in the main argument, we want to create a new language demo, i.e. a new GUI, and we want to set it visible. So we do demo.setVisible true. Okay, I went through that very fast. Does anyone have any questions about it? Like I mentioned, and I'll mention it again, a lot of this you just gotta like memorize. I doubt she's gonna give something this long on an exam. It might be a bit too much. You should focus more on like learning how to do the earlier questions with the classes and inheritance and everything. This question you could memorize, or even you see like how some of the naming and labels are very self-explanatory. One new label, J label, whatever you name it, equals new J label, yada yada yada. You add it to the panes. J text field, J button, right? You're starting to see how this is a bit straightforward and naming is a bit obvious. Okay. And now here comes a bit more like what's more used to, you're used to saying like problem solving type thing. So remember we want to set it so that when we click the close button, the first time we click it, it prints a message in red, and we don't want it to close immediately. We want to first print a message, are you sure, in red? Second time, are you really sure, in red? And the third time, it should actually close. So remember how we initially had the close attempts here? So we're going to use that. And we had a new window destroyer. So this is the window listener. So how do we do that? Well, we wanted to set, so if we click at window event E, so this is the actual click of when we click the close button, we increase the number of close attempts, right? And this is where we check if this is like, I think, simple CS111. If the close attempts is 1, i.e. we click the button once, then display label set text, are you sure? And we set the color red, right? So display label dot set foreground, color dot red. Okay. Otherwise, if the close attempts is 2, we display label and we set the text, are you really sure? Right? And we don't need to set the color again because it's already red. Right? So are you really sure? Otherwise, we system exit. Right? So this is where we have to use the close attempts, and we create this here as a window listener. Right? Window destroyer extends window adapter here. So this is a part of where these go in. So do you see how this comes from there? And yeah, this is pretty straightforward. We keep track of the close attempts. If it's 1, we print are you sure in red. If it's 2, we print are you really sure, it's still in red. Otherwise, we exit. Okay. Does anyone have any questions? I went through this pretty fast. Any questions at all? If anyone does need to leave early, please fill out the feedback form though. Any questions? If there are no questions, let me boot it up. So you see, I see how I have it loaded here. Right. So if I run it, see here, there you go. Editor GUI, got a label here, got a little drop down, language, English to Spanish, Spanish to English, it doesn't really do anything. We got our first like area here to label, got text input, modify text, text input, 2 buttons. Once again, this doesn't really check the input, so it's perfectly fine. And then we have the close button. So look here, if I click it once, prints, are you sure? Click it again, are you really sure? Third time, it exits. Oh, ignore that. But yeah, so that's pretty much it for that question. It's like 81 lines of code. So it's not bad, but I doubt you might be asked something similar to the next question, if anything, when it comes to the GUI, because most of this is just straight up memorization. And as I mentioned, it does seem a lot, but once you realize it's just, if you want a new menu, J menu, name whatever you'd like, new J menu, menu items, menu bar, you add new menu items, container, J panel. Most of the naming is self-explanatory. You create it and then you add it, you create it and then you add it, etc. The more problem solving portion of it is this part where you had to create a window closing function that, based on the number of times a user clicks the exit button, would then either print something to the screen, or then exit, etc. Yeah. Any questions? Any questions at all? Yeah, so you're gonna get something more like that, more likely this is the case. I'm not sure, but I feel like this would be more of a digestible thing. I'll wait a quick second for any questions. Okay. So then this question is then asking, consider the following Java class that is used to create and display a GUI. The class has exactly 3 methods, 2 of which you will write. Okay, so class P1 extends JFrame, JPanel center, a helper method to create a button and add to a specified panel. So you have a make button, creates new button and adds to the panel, takes in a panel and name, etc. Constructor method and a main method. Okay. So main method, remember if we look back to what we did here, what was the main method? We basically create a new instance of the GUI and we set it visible. So what do? Main method's pretty much the same thing, right? Public static void main, P1 GUI equals new P1. You can name whatever you want. And we can get and GUI.set visible, true. Okay. Straight up memorization. That makes sense. You create a new instance of the GUI. Remember, we have class, and we're going to have a constructor. That constructor is going to be here. All right. GUI.set visible true. Okay. And there you go. It's the main method. As for the constructor, once again, a lot of this, you see how it's memorization. So you super, set title P1. See the title here is P1 right here. So set title P1, set size, whatever you want to size, whatever size you want to make it. Container, content pane, get content pane, set layout, border layout. Now we got to create a new center, new JPanel. Content pane.add center, right? And we want to have the border layout be center. Once again, ignore the border layout stuff. That's more CSS. I say just memorize it. We want a new button panel, right? So that's for this little button panel right here. So we create it, we add the button panel to the content pane, and we set the button panel to a new grid layout, i.e. this is going to be one row 3, 1 column, 3 rows? No, 3 columns, 1 row. Yeah, 3 columns, 1 row. 1, 2, 3. Yeah. Once again, grid layout, memorize. I think it's rows by column. Let me make sure. Rows by columns. Rows by columns. Yep. Rows by column. One row, 3 columns. And we add buttons. Right. So this is, we used remember how we have a function, a helper function to create the button. So this is mostly to like reduce the amount of code. Right. So we make the button, right? Button is we always pass in the button pane 1 because that's the pane we're adding the buttons on. And we want to pass in the name. So we got red, orange, green, whatever you want to name it. And yeah, so this is basically, if you go back here, you see how, like I'm telling you, this is all this memorization. You see how this is all just right here. J button, check button equals new J button, whatever you name it. Button pane 1 dot add check button. Same thing here. You create a new button, whatever you want to name it, and then you add it to the pane panel. Is that a pane panel? Panel, yeah. Been saying pane the entire time and no one even corrected me. But button panel, red, button panel, orange, button panel, green, does this. So that's where you use the helper function. And in all honesty, oh, here you must apply the method make button. So you got to use the method here, helper function. And it just makes your life easier, right? And that's a nice part about Java. Like if you see something, code that's repeated multiple times, just make it a function and just use that, right? That's a good thing about like Java and not even, I think C++ as well, but like that's just the idea of object-oriented programming, is to avoid repetition, make code cleaner, easier to read, and just overall easier to write. Okay. Does anyone have any questions? Any questions about these parts A and B? All right. This problem, you will provide modifications to the code given in the previous problem. So at the center panel, color changes colors to red, orange, or green as the 3 buttons are clicked by a user. Your modifications should add one standard method to class P1 to program all responses to user actions. Okay. Okay, so whenever Okay. So first part, the title line of class P1 must be modified. Write the new title line that should be used for the class. So we want to look at P1. So it already extends JFrame, but we also wanted to include the interface that keeps track of the action listener. So so public class P1 extends JFrame and implements action listener. Oh, someone's in the chat. Never mind. Okay. So you just gotta add, ignore my brother singing in the background.
The back.
So you just gotta add implements action listener.
Gotta get some black, get some white.
What's wrong with you? I'm sorry for that. Public class P1 extends JFrame. So we implement action listener. I want to scroll up a bit. See how this same thing. I don't think we use action listener here. But because we want to use by using action listener, we basically get to use methods such as here. So we have action event E, and by using action listener, we then have access to the method. So e.get action command dot equals red, etc. Equals orange, equals green, right? So by implementing action listener, we then have access to all of these methods and variables that are from the action listener subclass. Okay, so that leads us into part B, which then says write the full code for one new method that should be added to class P1 to allow it to respond to button clicks. So we want to add a new method, public void action performed. So I think this is another one you override from action listener. So we have an event that happens. This is the button click, E, and we're checking if the button that we click, if e.action command, if it's red, then we already have center defined. This was defined here, JPanel center. We want to set the background color of it to red. Okay. Otherwise, if the button we clicked is orange, we set the background color to center to orange. And lastly, if you could also use an else statement, you don't really need an if, but if it's equal to green, we set the background color to green. Okay, pretty straightforward. This is where we get this ability from action listener, sorry. And this is basically checking, is it red, is it orange, is it green? Remember how we declared it as red, orange, and green, right? And based on what color it is, we set it to the corresponding color.
No.
Shut up. Right? And lastly, because we have to add this to all the buttons, we also need to add an instance of this method in the part where we create the button, not this part, sorry. In the part where we create the buttons. Because now every button, not only to having a label and adding it to the panel, we also need to add a listener for them. That's what we have to do, b.add action listener based on here. So we have a new button, B, and we have to create a new action listener based on that button. So we do b.action listener, this is basically saying whatever action happens to that button. Okay. So we add it to the end of every button. Each button has its own action listener right here. Okay. And yeah, that's pretty much it with GUIs. A lot of this, once again, gotta memorize. It's hard to like problem solve it. You could like the most problem solve-ish part of it is probably like the if statements, how you organize it, but that really isn't too bad if you know what you're doing. And yeah, does anyone have any questions? Any questions about this problem? Any questions at all? If there are no questions, let me show you guys where we're gonna find this. So we go to Learning Commons website. I'll go to resources, CSCI resources. Okay. We got CS review sessions here. So you'll find it under 212. Should be here for Chyn. Right here. Okay, so once this is ready, it should be posted. Yeah. So if you also want other review sessions, feel free to look at 220, 320. I don't think any of you are taking 111, maybe 211. But yeah. If there are no questions, please fill out the form. Once again, if you have any questions, speak now or forever hold your silence. And yeah, if there are no other questions, I think we're good to go. Once again, sorry for we couldn't really help that much on the GUI. We didn't. I took it with Kakamlar. He didn't really put that much focus on the GUIs. Because once you see, like, as you go later on, deeper in your CS career, there's just so much better alternatives to the Java GUIs. Like actually using HTML, CSS, and JavaScript is much better, in my opinion. But it's still useful. It's still useful to know the GUI if you want to make something quick project. And yeah, if anyone has any other questions, feel free to ask them now, or I think we're all good to go. Thank you all for this review session. Thank you, Xian. He carried most of the load today. With the classes in the first 4 questions, so everyone should thank him. And I think we're good to go. If anyone has any other questions, have a great day and good luck on your exams, everyone. Good luck on all your finals. Please do fill out the form. A good place to stop there.